Hello friends, this video deals with the calculation of remaining oxygen time from an oxygen cylinder. The time remaining if the oxygen was provided to the patient at current flow rate is given by the formula current cylinder pressure multiplied to the conversion factor of the cylinder and divided by the current flow rate. So in this video we'll be talking about some basic terms and some basic formulas. So let us begin starting with the conversion factor. This is unique to the cylinder and is calculated by the formula max volume divided by max pressure, meaning the maximum volume of uncompressed gas that can be accommodated in the cylinder and maximum pressure of gas in the cylinder respectively. So now for this, let us be familiar with the common cylinder markings. First is pH, which stands for hydrostatic pressure or test pressure and shows the pressure that a cylinder has been tested up to for safety. This is usually more than the actual pressure to which the gas is filled in later on. PW refers to the working pressure and is the pressure of gas to which the cylinder is filled up. W is the weight of the empty cylinder, that is without the oxygen filled up, and V stands for the internal capacity of the cylinder and is the volume inside. It is then followed by the manufacture date of the cylinder and then the ISO number. So, these are the common cylinder markings. In this example, we'll find that PW, which stands for the working pressure, is 150 bars and it is followed by the symbol of pH, which stands for the hydrostatic pressure or the test pressure and is 250 bars. This is followed by W, which stands for the weight of the empty cylinder and is 16.5 kgs in this case. Then comes the number 10 and this stands for the internal capacity of the cylinder. So, the time remaining for the oxygen supply is calculated by the formula current cylinder pressure multiplied by conversion factor and divided by the current flow rate. Conversion factor is unique to the cylinder and is calculated by dividing the maximum volume by the maximum pressure. Here, the pressure unit used is PSI, which stands for pounds per square inch and is the maximum volume used is that of uncompressed oxygen, and note that 1 bar is 14.5038 psi. So, in this example, we first calculate the volume of uncompressed oxygen inside the cylinder. If P1 is the atmospheric pressure, which stands at 14.696 psi, and V1 is the unknown volume of uncompressed oxygen inside, and P2 is the pressure inside the cylinder, which is 150 bars in this example, converted into psi, and V2 is the volume of compressed oxygen, that is 10 liters in this case. Then, using Boyle's law, we can calculate V1, which comes out to be 1480 liters. So, this is the volume of uncompressed oxygen that has been filled up inside the cylinder. Now, to calculate the conversion factor for the cylinder, we can divide the maximum volume of uncompressed oxygen, that is 1480, by the maximum pressure inside the cylinder, which is the PW in this case, and it comes out to be 0.68. Please note how we have used PSI instead of bar. Now, let us suppose the pressure gauge shows 500 psi while oxygen is being consumed at the flow rate of 2 liters per minute. Then the time of oxygen remaining from the cylinders can be calculated as 500 multiplied by the conversion factor of 0.68 and then divided by the flow rate of 2 liters per minute, which gives 170 minutes. So, in this example, it takes about 170 minutes for all the oxygen that remains to get used up if the oxygen was delivered at the same flow rate of 2 liters per minute. Please note that this is an approximate value and the cylinders must be replaced beforehand. Thank you.